In this video, we'll spend some time going through the semantic caching policies offered in Azure API Management for your AI APIs. During the introduction, we already established that APIs are at the core of GenAI development, and that now more than ever, these APIs need to be better managed, secured, and governed. Here, we'll see how you can minimize costs while making your applications more performant by reducing the overall number of API calls hitting your backend. Let's start by looking at a normal implementation of a client app being served by an LLM backend. For this example, we'll look at one of each, but in most real-world implementations, you'll have multiple clients talking to multiple backends. So, a user lands on your application and sends in a query. Let's call it query 1. This query is passed along to the underlying language model, which generates a completion that's sent back to the user. The same or yet another user comes in and asks the exact same question with the exact same words, or they could be asking the same question with different verbiage. Each of these subsequent queries will be passed along to the backend, costing you tokens and time as the model requires some time to generate a response for you. With each of these calls costing you money, you can imagine how expensive it can get to sustain your GenAI applications as your user base grows. So, how does the semantic caching policy offered in Azure API Management help solve this? Now, with your APIs being managed through an Azure API Management instance, let's revisit our example and see how the workflow changes. When a user lands on your application and sends in a new query, the request will be passed to the language model. Then both the prompt and the completions are stored in the cache service. If the client application receives queries that either contain specified keywords or are semantically similar to any of the prompts in your cache, Azure API Management will not pass the request to the backend, but will instead retrieve the corresponding completion from your cache and send it back to the user. And if your application receives a new query, the normal workflow kicks in, sending the call to the backend and storing a new entry in the cache. Let's dig deeper into these policies. The first policy you need is the Azure OpenAI Semantic Cache Store policy, which is responsible for storing the prompts and completions in your configured cache service. Note here that you can either use in the built-in Azure Redis Enterprise cache, or you can add an external cache as long as it is Redis compatible in Azure API Management. In this policy, you are required to specify the time to live for your entries in seconds. The second policy you need is the Azure OpenAI Semantic Cache Lookup policy that performs various tasks. 1. As you define the policy, you will provide an ID for an embedding model that will vectorize your entries to store them in text and vector pairs. You'll also provide a value for the score threshold, and these will be used to determine how related the stored prompt should be to the incoming prompt to trigger the retrieval. Based on the result of the vector search, this policy will retrieve the completion that will be passed back to the user. With these two policies, you will be enhancing your GenAI system's efficiency and performance by reusing completions, reducing latency, and the overall cost of your API calls. In this video, we've only highlighted the Azure OpenAI specific policies, but we have the generic policies that cover all the models provided through the Azure AI Model Inference API. This is just one of the GenAI features in Azure API Management. Check out the other videos in the series to learn more about the other token management policies. Don't forget to like, share, and subscribe for more content.